Great. Good afternoon, everybody. My name is Austin Majide. Today I'll be a moderator and I'll be here to welcome Mr. Abhay Samart. I hope I pronounced that right. Okay. So Mr. Abhay Samart is the Director of Systems, or the Director of Systems R&D at Instruments, Aero Defense and Government Business Units. He's also the adjunct faculty member at UT Austin's McCombs School of Business and ECE Department. Previously, he was the president of engineering at Hiller Measurement, leading multidisciplinary engineering teams focused on aerodynamics, automotive, and semiconductor systems. Mr. Abhinay has a very strong background in RF and wireless communication, with extensive R&D experience and and a PhD from the Indian Institute of Technology, along with his master's degree in computer science and electrical engineering from renowned universities. So without further ado, I would like to introduce Mr. Abney Samar.
Well, thank you very much for the kind introduction. And very happy to be over here and spend this afternoon with you all. Really good presentations throughout the day, and really applaud the society to organize this event. So today, I will be speaking about various advances in space applications, including immersive data applications. So we'll definitely be talking about that. So let's jump right in. So the past 18 months, right, if for all of us who are in the field of space and space applications, it's always been an exciting time. But the last 18 months, especially, have been super exciting, super fun, right? And sort of month after month, we hear this amazing news of the successes that we are seeing in the space program, not just within the United States, but globally. And so if there was any exciting time to be in space for all of you who are studying, it is now, right? If you think about the successful deployment of the James Webb Space Telescope, the Artemis 1 mission with their SLS and Orion programs has been in the news quite often. The spacecraft impact and asteroid deflection with the DART mission that has been very successful. We have the Starlink deployment in Ukraine. And it's amazing to just think about in terms of numbers. We've had about 186 launch attempts in 2022 by itself. And then more than 90% of them actually reached the orbit. And just a few months ago, folks who are following the global space initiatives that are going on in India, they had a successful launch of the Chandrayaan space program, the Chandrayaan 3, that reached the south pole of the moon. And now, so we have a complete 360 degrees evaluation of the moon's, of the lunar surface. And so when Bill Nelson, one of the NASA administrators, says that 2022 will go down in the history books as one of the most accomplished years across all of the NASA missions, that is a very true statement. So it's an exciting time. And if you all are studying about aerospace engineering, about space in general, this is a great time to be in the space. It gives me goosebumps every time when I think about everything that is happening around us. Uh, and it's not just about what has happened in the past, but in general, the trends that we are seeing in the space industry across the spectrum of whether it is the launch services, whether it is satellites, the habitats that we are looking in the space with the deployment and the growth of the low Earth orbital economy, and also the advances we are seeing in the ground segment with the multi-orbit and the multi-frequency ground station support. It kind of gives us an idea about what are the kind of technologies that space is going to see in over the years to come, and also about what kind of the advances and the applications that we want to see over here. All of these are exciting trends. I am especially kind of very, very optimistic about the economic benefits that we're going to see with the launch services being democratized, right? With the low Earth orbits, with the decommissioning of the International Space Station in the next maybe by 2030 or so, and with the NASA's mandate to kind of commercialize space applications, where NASA now becomes one of the customers of the various companies, commercial companies that are launching satellites into the orbit. I think is really going to uh, 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 increase the amount of space satellite launches that we'll see, and will allow us to really go beyond the moon to explore the space even more. Right, we are seeing a lot of satellites being launched in this low and medium Earth orbit satellite. So that's going to really give us a full coverage of the entire space beyond the Earth, so that we can do more scientific research to advance what can be beneficial for humanity in this space. Cyber considerations are also going to be very critical. With the launch of the space as a fourth arm of the U.S. Department of Defense, I think the considerations of cyber security and how we can keep our critical infrastructures secure and safe is going to be an exciting trend to watch out as well. And so just to summarize, very not definitely we are seeing a lot of exciting things in 2022 and 2023, but the future looks even more promising with all of these trends that we're seeing in the space industry. Now, the trends are great, but they do come with their own set of challenges, both from a market and a business perspective, and also from a technology perspective. And we all, as the future aerospace engineers, have to be aware not just of the trends that we're seeing and the promises that we see, but also of the challenges that we are seeing, so that we should be prepared to face on these challenges head on and be able to come up with innovative ideas to overcome these challenges. From the market side, the challenges that we're going to be seeing is in terms of increased downward pressure on cost. You know, as we are seeing this democratization of space applications. Yeah, I was talking about the increased customer cost pressure. There's also going to be increasing competition from the market. Right now, it's going to be a truly a global playing field that we'll have to compete in. And then the fourth challenge that is listed over here is in terms of capacity and expertise. Right, this is where it's a golden opportunity for you all, the students in the conference, to be thinking about what are the kind of skills that you all should be learning about, so that you can address that specific challenge about bandwidth capacity and about the expertise that this wide ecosystem of aerospace companies are going to be looking for. So the exciting part is for you all as students is going to be that as you finish your courses, your undergraduate, graduate programs, there's going to be multiple companies looking for the type of skill sets that you all will be bringing to the marketplace. From a technology perspective, the challenges are going to be how do I scale these programs to the production volumes, right? And so National Instruments is in the forefront of trying to help with those challenges. How do you work with the more complex payloads? You know, as we are trying to solve new problems for humanity, the type of payloads that we'll be looking at, the type of scientific experiments that we'll be looking at are going to get more complex. And so that's going to be one of the challenge that we'll have to see as we send more and more crew with these space explorations. The quality and the reliability and the safety of our crew is going to be paramount, and that's why it's going to be increasingly put a pressure on making sure that the test of these artifacts is done correctly. Having more software, more immersive data, and autonomy is just going to add to the further complexity. So it's not just the complexity of the payloads, but the complexity and the integration of all of these sensors and the data and the sensor fusion that's going to happen is going to be extremely important. So as engineers studying in the aerospace field, we have to be prepared for some of these market challenges and technology challenges that we expect to see going forward. So here's just one example that I want to highlight about when I talk about the complexity of the systems, right? I spoke briefly a few minutes ago about the fusion of various types of sensors and various types of communication protocols and various types of signal processing artifacts that are coming together in these complex payloads. And just this picture shows you how in a space station of the future, you're going to have an integration of power electronics, channel emulations, telemetry tracking and control. You also need to be looking at the full rate digital signal chain that is going to be integrated throughout the various pieces of this satellite communication, not to mention the environmental testing and the testing of these complex payloads that have to be done as well. So we all had to be prepared for these complexities that we're going to see coming forward. Um, when I spoke about the democratization of the low Earth orbit satellites, this is just when I look at this picture, it just amazes me to see how many initiatives that are going out globally, all the way from the east with Hanwha in South Korea, trying to put about 2,000 different satellites planned in the next 5 years or so. We have, like I spoke briefly about the Indian missions that are going on in Europe and also, of course, in the US with Amazon launching its very ambitious Kuiper program, Viasat having plans for about 300 satellites planned over the next 4 or 5 years or so. So this is just going to increase the number of employers that are looking for the type of skills that you all are trying to gain. So you have much more wider scope of companies that you can look for joining and in making a impactful contribution. So there are various challenges that I spoke about. Over the next 5 or 10 minutes, I want to briefly dive down into specifically into immersive data, which is the scope of my or the main focus of my presentation. And so before we look into immersive data, I thought we'll just take a step back and look at the brief history of visualization, right? So if you think of it, humans started recording and sharing data visually as early as even at the beginning of the 17th century or even earlier than that, where the initial visualizations were basically tracking the planetary movements that were recorded and charted visually by the early astronomers who essentially used these visualizations to help communicate the movement of various planetary bodies. If you fast forward to the 1800s, the visualizations or the use of visualizations was far more widespread. And we also had now monetary transactions that were being visualized very commonly using bar charts, like I've shown on the picture on the right hand side. We also had precise geospatial maps being drawn and shared widely. So if the 1800s were kind of the golden age of data visualization, when standards were more widespreadly developed and adopted, and we started seeing more and more of these visualizations that started coming in. With the introduction of more computers in the late 1900s, we started seeing more developments in software-based visualizations, which exploded as basically as novel methods and techniques to be brought to light. So utilizing basically computer science and graphics, analysts were now able to store and compute much larger, more complex data sets using virtualized instruments. However, these virtualizations or visualizations were still limited to flat screens, like two-dimensional screens. And we had some three-dimensional screens, but they were still expressed on two-dimensional screens. So you can think of it as a 3D image being trapped within a 2D method of expression. And so this is where basically led to the concept of what's known as a immersive data visualization. So what is immersive data visualization is basically taking a two-dimensional representation and bringing in data from sensors that are connected to it. So basically converting it into AR or augmented reality and virtual reality technology to essentially create a single holistic environment. So you're now basically using the user's data set, the situational awareness that is being created by these sensors that the user is wearing, and bringing that data into a data experience that is being created. So basically, the user can literally now step into that data, touch it and feel it and manipulate it in real time to perform more complex analysis. And this is one of the trend that is really going to change the way not just we kind of think of space data, but also in the way in which we train our astronauts, we train our pilots going forward, so they can basically, in the safety of their training environment, get themselves immersed into the space so that they are prepared for what's going to happen beyond the physical beyond the physical world that they are looking in. Now, often you will see 3D charts in virtual reality or augmented reality being called immersive data visualization. Uh, I want to draw a distinction that is really more of a 3D visualization. So I want us to make sure that we don't confuse a 3D visualization with fully immersive data visualization. The key difference between the two is that the methods that are used to visualize the data in multi dimensions and the user's ability. So for me, immersive data is about that ability to show the data in three-dimensional and have the ability for the user to visualize this data and immerse themselves within the data sets so that they can fully experience it. And that is really what 3D or a fully immersive data visualization is all about. Sorry. So just want to quickly talk about the three data trends and the technologies that we'll see over here. I'll start with the picture that I have on the right. This is a market survey that talks about how the growth of immersive data and AR, augmented reality, virtual reality technologies is going to evolve by 2031. Immersive and non-immersive data is definitely going to expand, but there's research also talks about what's known as marker-based and non-marker-based. I'll talk about marker-based briefly because the trend is definitely seeing there. In marker-based technologies, you have a specific trigger point where you're not immersing in all the data around you, but when a specific topic or a object of interest comes within the view of your AR VR machines, that triggers the immersion. So that is really helping you to remove the clutter out of your system and then focus based on. So my hunch is, which is supported by this market research, is that you also see, in addition to immersive data, marker-based AR VR technologies also coming in. Okay, so I just wanted to throw that out for you. But now back to the trends we're seeing within the scope of immersive data. The first question that you may want to ask is, why are we adding immersion into this? Simply beyond providing sort of more of an engaging way to view data, the addition of immersion also makes the visualizations much more useful. Immersion, when applied properly, allows users of all skills levels to ingest large amounts of data or large amounts of complex data without really increasing their cognitive load. For example, a typical situation requires the user to understand and develop insights from a spreadsheet containing millions of cells of individual data. A two-dimensional view is very difficult. So this task will basically take a lot of time to complete because the way the data is presented is not really optimized for ingestions and is inefficiently displayed to humans who primarily, we as humans, primarily are used to using our visual senses to understand data. So I believe that adding of immersion and three-dimensional immersion is really going to decrease our cognitive load and make us more efficient in terms of understanding and engaging with the data. Because the human brain, right, as incredible as this, is is not just wired to process data in a particular two-dimensional format. We have different dashboards and other 2D visualizations. They step in the right direction, but really it kind of limits the way we want to think about it. The multidimensional display of data will basically allow our brains to ingest the data in a way that is easiest for us to understand, for our minds to understand, and intuitively identify trends and patterns in multiple large complex data sets. So if that's why we want to add immersions, what are the quantifiable benefits? With immersion, data sets can basically be visualized in digestible experiences that can convey complex insights with ease, allowing teams, basically distributed teams. So one of the things that's going to happen is we'll basically have now multiple teams all over the globe trying to understand the data correctly. So basically, visualization or immersive data is basically going to allow teams to understand two seemingly contradictory insights, which may be true simultaneously. And so you can basically look at it from different perspectives, something that is very hard to achieve in a simple two-dimensional view of things, right? The other also benefit of immersive data is that multidimensional mental models of data sets can be built by different viewers. And so basically, this will allow everyone to skip the mental model step directly into a multidimensional approach of looking at the data itself. So what you're going to see as you graduate from colleges and go into the workflow or go into the industry is more and more integration of immersive data into the workflow that you'll be using for doing your work. And first and foremost, the benefit of that is going to be a lowered cognitive load, basically less brain power to complete the analysis and allow us to go more deeper and look at the data in different ways. So, of all the trends that I explained earlier in the space industry, the immersive data trend is the one that's going to be highly exciting and beneficial as we go forward. Right. And so just want to so that's kind of the immersive data. Just want to wrap up about what we as National Instruments, as NI, are seeing. We're definitely seeing a lot of trends or market drivers. The US defense spending is increasing. There's more and more investments going into space and also in commercial aviation. So we are definitely seeing a lot of increase in test and measurement within our field. Our mission, NI's mission, always has been to equip engineers and enterprises with systems that accelerate productivity, innovation, and discovery. And we continue to work with leading customers in various industries, especially aerospace defense, to make that happen. We have a broad set of hardware and software portfolio. So these are basically, like I talked about, immersive data. Data is going to come from different sensors. So we have instrumentation, data acquisition and control, interfaces to communicate with not just with the systems under test, but also with different instruments, and then application level software to enable those applications. And we look across all of the various aspects of the workflow, all the way from launch to satellites, whether it comes to launch operations or whether it comes to electronic ground support equipment, or also the environmental, structural, and mechanical test applications. So that's kind of why we are excited both as consumers of these advances in the space applications, but also as kind of contributors to advances in tools and technologies that will allow us to bring all of these space trends into a cohesive manner in the next type of space applications that we are going after. So that is my last slide. I will stop over here and pause for any questions.
Okay, if anyone has any quick questions, just raise your hand. Okay. So, no questions. Abhay, I really thoroughly enjoyed your presentation. I have a master's degree in space architecture, so you hit on all of the hot topics that we used to talk about. So, just really, really exciting and very, very interesting. So, thank you so much for taking time again out of your busy schedule to join us, and of course, Hakeem, you as well. I didn't say that after your presentation, but thank you guys so much for joining us and presenting this great, great information. We really appreciate it so much. Okay.
Thank you.